Okay, so this is work solution 15, and it's another pressure vessel problem. It's a 2-meter long tube. We've been told the internal diameter 10.5 centimeters. Been told the thickness. So the thickness is 1 millimeter. And inside there's 28 bar of a fluid. The Young's modulus of the vessel is 200 gigapascals, and we have a Poisson's ratio of 0.3. Calculate the original internal volume and the change in volume. So in comparison to the previous worksheet, the only difference that we're doing here is we're going to use the specific volume formula. So you don't have to have the terms to such accuracy this time. So first write out your values. The length of the vessel is already in SI units, meters. The internal diameter, watch out whether that's internal or external. Internal diameter is 10.5 centimeters. So that will be 0.105 meters divided by 100. 1 millimeter thick, divide that by 1000, and that gives me 1 times 10 to the minus 3 meters. 28 bar, so a bar is roughly 1 atmosphere, 100,000 pascals, so that's 1 times 10 to the 5. So make the 28 times 10 to the 5, maybe we could change that to 2.8 times 10 to the 6. 200, we've got a prefix here of G for giga, so we need to get rid of that and make it into a 9. So times 10 to the 9, 200. And then finally the Poisson's ratio of numbers doesn't need any conversion. So this gives us the SI numbers of the length, the diameter, the thickness, the pressure, which I'm leaving times 10 to the 5, E in terms of Newton pascals, and the Poisson's ratio. Let's just carry those terms forward. So first of all, let's have a look at the original volume. So the original volume, we're using pi d squared over 4 times by the length. Okay, so that's the regular formula for a cylinder. Put our numbers in and we get a volume of 0.01738 meters to the power 3. Now this is the special formula that we can use on our formula sheet for change in volume for cylinder. So this time I'm going to substitute our numbers in there. So the pressure, okay, so that's coming from there. Next, the internal diameter, so we've got an internal diameter that's going to go in there. We've got the thickness, so we've got that value going in there. Young's modulus, the E, that's going to go in there. Okay, put it all in your calculator, open a bracket, and then we have 5, take away 4 times the Poisson's ratio, so Poisson's ratio, that's going to go in there. And the formula in the formula sheet is giving us the volumetric strain, so we actually want to find the change in volume, so we're going to take that formula and multiply it by the volume, the original volume there. So that's going to go in to there, okay? So I think the formula on the formula sheet is that. Okay, so very simple transposition required to do to this problem, and that's it. So that's our result, which I think compares to problem sheet 14. So you can do a comparison of how the rounding changes.